Okay guys, so we just finished the basic theory of what is a linear regression. So what we'll be doing next is we'll be doing an practical example of how to actually implement a linear regression using your data set. So as I told you, we learned about the majority of the data sets in the earlier classes. So how these data sets are going to actually make some sense. So we'll be using the data sets. We'll be creating a model. So what is a model? If you give the data, so it will generate the model or nothing but how the data is getting related. So if you have all this data and we can get to know how this data is actually getting related, so then it will be the best example of how you are actually able to predict new values of your results. So this is nothing but a data set that we right now have. So this data set is called a salary data set. So what is this salary data? It is pretty simple. In the x-axis, we have years of experience. In the y-axis, we have nothing but salary. Instead of x and y, we can say that there are two columns here. So two columns stating that one is years of experience and the one is nothing but our salary. For 1.1 years, if it's getting 39,343 rupees. For 1.3 years, it is 46,205. For 2 years, it is 43. See, now the relationship is not linear. So there is no one single line which can pass through all the points. So that is why there is a need for fitting the best fit line. So what is the need for fitting the best fit line is pretty simple. So we'll take all the data x versus y. So we'll see how exactly our values are getting mapped. Then we will see how why should we draw the best fit line, and we'll do the programming example of all these things. So I will post this salary.data CSV in the portal, so you can download that and you can use this salary data.csv. So this will give you a better idea of how actually working. So it is nothing but we have two variables, years of experience and salary. So which will become y and which will become x. Pretty simple, guys. So this is nothing but our x. So like it is nothing but like the number of apples. So this is nothing but the cost of apples. So this is x and this is y. So we need to find out the relationship between our x and y, whether it is it will be always in the form of y is equal to mx plus c, because we are trying to draw a straight line at the end. So in the end, we are trying to draw a straight line. However, we will get an equation for the straight line. So we'll discuss all about that. Firstly, we'll start with how actually we are able to use this particular data, that is nothing but salary data. So years of experience we have and the salary we have. So what we'll be doing is we'll be doing our first machine learning algorithm, that is nothing but our linear regression. So after doing our first machine learning algorithm, that is linear regression, what we'll be doing is pretty simple. So we'll try to predict our salary using our years of experience. So if I have 10 years of experience, so what will be my approximate salary? So this is what we'll be trying to predict. We'll give our own values also. We'll check how our algorithm is also working. Okay. So first step is pretty simple. So we'll just open our Python program and we'll start coding. To start coding, this is how we start coding. First, we'll try to include the libraries that we want to. So the first part is including the libraries, but before including the libraries, we want to install some more libraries. So how do you install libraries? Open your CMD. So here you will have your CMD. I have told you pip install the library name. So what is the library that we will be trying to install? We by now we should have already installed our respective libraries, that is pandas and matplotlib. So I will try to install all the libraries. So I will install matplotlib first. So if it is already installed, it will tell you that requirement is already satisfied. Okay, fine. So we'll try to install pip install pandas. So we know that panda is a data manipulation and CSV reading library. So that is also installed. But some new libraries that we need to install is nothing but pip install numpy. So numpy, I will tell you what is numpy. Numpy is nothing but the numerical library in Python. So why numerical library? Because the data that we are dealing is not 5, 10 or 15. So it has thousands of rows and columns of data. So that is why we need some number manipulation library called as numpy. I will tell you where it is exactly used when we come to the use cases. So this also we will need to install pip install numpy. Then we will install pip install scikit-learn. So scikit is nothing but the library scikit/learn. So this is the library for the machine learning packages. So what we have in scikit-learn, all the machine learning packages, the linear regression, logistic regression, k nearest neighbors, whatever machine learning, important machine learning libraries, that is nothing but algorithms are there. All these libraries are embedded within our scikit-learn. So scikit-learn is an inbuilt package inside Python which has all the machine learning libraries. So if you want to do your own machine learning program that is nothing but not use a library, it is pretty simple. Again, you need to do all the mathematical formulas. Nothing but we need to find the best fit line, use the distance formula, calculate the coordinates and check how it is working. So this is how these things are working. So very important to understand why we need scikit-learn. It is doing our job very easy. So we don't need to worry about all the mathematical functions, how it is trying to do all those things. It has all the mathematical functions inbuilt into it, so all the machine learning algorithms can run with a single code. So with a single line of code, you can run all the machine learning algorithms. But you can do mathematically on your own without using this library also. It is nothing but writing down all the formulas, doing each and every manual step and getting to the result. But that is not necessary because we don't need to reinvent the wheel again. Since we have a set of all the formulas, if we understand the concept of how this algorithm is working, so that would be fine to solve our problem. So that is one thing. So 4 libraries we installed. One is matplotlib, one is pandas, one is scikit-learn. So NumPy, pandas, scikit-learn and matplotlib. So 4 libraries we installed. So you should install pip install those particular libraries. So how do we start off is pretty simple. So we'll import the libraries. So how do you import? Import pandas as PD. So why PD? This is the alias name that I am trying to give you. So that is how I am importing pandas. So the next package that I'll import is nothing but matplotlib. But since I told you matplotlib is a very big library, you don't need to import anything. So you can use you can just import a part of it. So there are 2 ways. So one is nothing but from matplotlib. From matplotlib you can import pyplot as PLT. So this is one method. Or you can use from matplotlib.pyplot import. So we'll just import only this particular thing. So import matplotlib.pyplot as PLT. So both are same. So you can either use from matplotlib, import pyplot as PLT. So this is also same. So this is also same. So you can prefer any one of them, both meaning the same. So what we are doing is we are importing the Python plotting for plotting our graphs. So we have imported pandas, we have imported matplotlib.pyplot as PLT. So this is nothing but our alias names. We can use it anywhere in our Python program because we don't want to type large names like matplotlib.pyplot in our program. We want to do our job very easy, so that is why we are using this. So then what we'll do is we'll import our NumPy package also. So import NumPy as NP. So I will tell you where NumPy is used. I already told you NumPy is nothing but a mathematical library. So whenever, see, one thing you need to understand is in an integer you can store a number, in a list you can store hundreds of numbers, but in case of data sets there will be millions of data. To make the data storage very simple, so we have a mathematical library called as NumPy where we can do mathematical operations with large data. So if you want to calculate our distance formula for 1 million data, if you can't put it in a list. So if you put it in a list, it will throw you an error stating that memory is gone. So to use large number of data, you can use NumPy. So NumPy is nothing but a library which helps you in using large data which are present in our data set. Okay, so now this particular task is done. We'll try to do some simple steps. So what we'll try to do is pretty simple. First thing is we need to load our data set. So what I'll do is I'll use this command called as dataset is equal to pd.read_csv. Okay, pd.read_csv. The name of my CSV file is salary_data.csv. So what is happening now? It is pretty simple. So we have our data. What is our data? Data set is nothing but a data type, which is nothing but our pandas data frame. So where have we told it as a pandas data frame? Whenever we read some data from the CSV file, automatically this will be a pandas data frame. Okay, so we will give the name of salary_data.csv. So one thing guys, very important, this Python program you have written, if it is in the same location, so nothing but your salary underscore data dot CSV is in the same location as your Python program which you are writing, then it must be in the then only this can be used. But if it is in some other location, then whole location needs to be mentioned. So guys, you can see that the thing is, I have placed it in some other folder. So I am mentioning it is in the S drive. It is in the folder called AI. Within that there is a content folder. Within that there is salaried underscore data dot CSV. So very important to understand that this is nothing but this is opening the CSV file. But to open the CSV file, it is very simple. Any program you need to mention where is it. So where is the directory of the particular file? How will the program know that it is in that particular directory or file? If it is in the same folder, it doesn't require the full path, because it will search through the first folder, same parent folder. But if you mention the path, it will go to the respective folder and search for the CSV file. So very important to mention the path. Most of them will get errors here itself. Okay. Now we have our data set done. So what we'll do is we'll try to print data set to check whether our data set is working or not. I mean, whether we have successfully exported it or not. So we'll save it as Python p11. Okay, Python p.py. So that is fine. Any name you can say. Okay, now I've got the data. What is this? Years of experience versus salary. So this is all telling me all the data that I have. So I have years of experience data and the salary data, 2 columns of data successfully imported. Good. So this is the first step done. Why is this the first step done? Because we are successfully able to read a data set from Pandas library and store it in a data type or a variable called as data set. So this is how we are doing it. Okay. Now what we will try to do is we need to extract the columns. So what is the columns that we will extract? We need to extract our data X and data Y. So what is X? Our X will be nothing but our what value, guys? X should be our nothing but our years of experience value. So X is nothing but our years of experience value. Y is nothing but our salary value. But what we'll try to do is we'll use this operation of Pandas, that is nothing but dataset.iloc. So dataset is this variable. So iloc is nothing but getting the location from the index. So what we'll try to do is X is nothing but our first column. But in case of our practical data sets that I showed you, it is nothing but like our diabetes data set. There are multiple columns. Okay, so what we can do is we can have a simple trick here. So what is the simple trick? So what we'll do is we'll use this colon minus 1. So what is this colon minus 1 doing is it will select all the rows and all the columns, okay, except the last one. So this is the trick. So what we are trying to do is our X is nothing but our first column, but in our practical data set our X might be all the columns. So this is just nothing but X and Y. But in case of our practical data set, we'll have X1, X2, X3, X4 and X5. So all this will become X. So then only one will become Y. So what we'll do is we'll try to take in all the data except the last column, because every data set the last column will be Y. So that is how the convention is. So I will take all the data except my last column. So all the rows and columns except my last column. Since here it is only one, so it will consider the first column. So that is how we are trying to do. It is nothing but a simple trick to get our value. So what is the values that we are trying to get? It is pretty simple. So from this we understood that while working with a regular data set, so whenever we work with a regular data set which contains multiple columns, so all the majority of the columns will be your X, that is nothing but X data. So the Y will be nothing but your last column. So in order to take in all the columns except the last one, it is nothing but colon minus 1. So this colon is telling that select all rows and columns, but this minus 1 is telling that please do not select the last column. So everything, that is all the rows and columns will be selected except the last column. Okay, so then we have to select our Y. So Y is nothing but dataset.iloc. So that is the command, but here we need to choose the values because we don't need all the indices part. So why we need to choose values? Because our data set contains this years of experience, salary, that is the name of the column. So we don't want to use the name of the columns, we just use the values which are there inside the column. So that is why we need to select the values also. But what is our Y, which is nothing but our last column? So here how many columns are there? 0 and 1. So which which I need to select the first index. If I select, so that will become 1, so values. So please understand here, so one thing it is very important in every data set that we'll be using. So x will be nothing but the data which we want to, which is nothing but our dependent, like independent variables. So x is nothing but our independent variables, but y is nothing but our dependent variable. So one thing is, if you have multiple columns, you can select all the columns except the last one. So your last one will be your salary. So that is how you will select everything except the last one. So that is why I have used this option called as colon -1. So this is telling that use everything except the last column. So then you will select the last column for the y, but since there are only 2 columns, we are selecting the second column. But second column, how do you address it? By using the index number 1. So that is how we are addressing it. Okay, now we got the data, but we need to do something. What is that? We'll see how the data is, because we need to see whether it is a linear data, non-linear data. Is it a straight line data? Obviously it is not a straight line data if you look at the data set, but we will see practically that is in terms of graph. So what we'll do is we'll do this plot.scatter x comma y. So plot.scatter x comma y will plot it. So then plot.show. So this is the code. So why are we doing plotting? Because we want to see how the points are actually distributed in our graph. So xy coordinates, how are they actually, whether they are linear or totally non-linear. That is why we are plotting x comma y. Then this plot.show is nothing but showing our graph. So if we run this code, what do we get? We need to get a graph at the end which is telling us how our x and y are related. Yes, see. Yes. So we can see from this graph that we have our values of x and y, but one thing is our x and y are not linearly related. So our x and y are not linearly related. So what is the thing that we should do? See, what we are trying to do here is we have plotted a graph versus x and y and it is not linearly related. So one single line cannot pass through all the points. So this is the knowledge that you should get from this graph. So next thing is pretty simple. So what is the thing? We need to draw lines and we need to measure the distance between this point and the line, and we'll see which is the best fit line. How? Calculate the distance from all the points, square the distance, then whichever has the minimum distance between the points, and that is the best fit line. So that is why you need the linear regression. What does linear regression do? It is nothing but finding out our best fit line. So whenever we have a line drawn in our x versus y graph, so we need to find out our best fit line. That is why we are doing this. So this here we are just comparing 2 values in our data set, that is nothing but a salary, which is y-axis, years of experience is our x-axis. So this is the plot of years of experience versus the salary. So what we can do now is pretty simple. So you can put the like title and also that is one part. So you can put the title such as data graph. So which is telling you how the data is being utilized. Plot.x label, you can put the label for x stating that it is years of experience. So this is one, and plot.y label you can put nothing but our salary. So this is the salary and this is the x label and y label. So if we try to print that particular thing, so you can see that this is the data graph, salary. So this is the salary and this is the years of experience. So this is how the graph is plotted. So we need to find the best fit line to predict our future value. So whenever we draw a best fit line, so if you want to predict our salary at the end of 5 years, so I can just interpolate. That is nothing but draw a line from 5 to the graph and see which is that particular point matching on the y-axis. So that is how we can predict the values, or that is how a linear regression predicts the values. So yeah. So this is done now. So next thing is pretty simple and pretty important that we need to learn actually. So what is the thing is pretty easy. Yeah, so the one thing that we'll need to learn before we start writing our linear regression program is, in any machine learning algorithm, as we told, that data is the important part. So whenever you give the data to the nothing but you give the data and you give the output, so the program will be generated. So basically what we try to do is we split our data into 2 parts. So one is called as the training data and the other one is called the testing data. So what is training data? What is testing data? It is very simple to understand. Suppose you have a child in your home, so you are teaching that child which is a cat and which is a dog by giving 100 images of cats and 100 images of dogs. So you have photos of 100 images of cats and 100 images of dogs. So you are making the child understand that which is the cat and which is the dog. So step number 1 is, before giving all the photos to your child, you can remove certain amount of photos. For example, out of 100 photos, you can remove certain amount of photos and keep it as a separate part. So the rest 80 photos you can give the child and tell that this is the cat, this is the dog. So you can help him understand that which is the cat and which is the dog. So now you have successfully trained the child. Okay, so you gave 80 images. Out of the 100 images, you took out 20, kept it aside. The 80 images that you give, the child learned through it. But how do you understand whether the child learned it properly or not? So you don't give the same 80 images that you have taught it using it, but you will give the 20 images which were not a part of that particular training images. So that 20 images is called as testing data. So using the testing data, we can evaluate how actually our algorithm has been trained and how actually my algorithm is working properly. So this is how a machine learning algorithm works. So very important to understand. So we have the data, that is the data set, we have our X versus Y. So we have X data and Y data, but major thing is we need to train that X and Y data. So how do we train that X and Y data to our algorithm? So the total data if we give for training, the problem is how will you test the data whether it has predicted properly or not. So that is the reason, right? So if I have 100 like the quantities or 100 rows and columns of salary versus years of experience. So if I give all the 100 for training, so then how do I test it against the other data? Either I should give random data, or I can make my part of the data that is nothing but if I have 100 data, I can use my 80% of data to train my algorithm, machine learning algorithm. So after training my machine learning algorithm, what I can do is I can easily use the 20% of data to check whether it is being predicted or not. So that is how actual machine learning works. So in all machine learning concept, very important, whenever you have data driven from the data set or any other possible ways, every data must be split into two parts. What is the split data? The split data is nothing but training data and the testing data. So what is training data? Whenever you have your data that you need to train it for your algorithm. Best example is whenever you want to train your child which is the cat and which is the dog. So you give out of the 100, you give 80 images to train for cat and dog. So you train using those 80 images and test your child with the help of those other 20 images. So that is how machine learning is working actually. So what you are trying to do is, with the 20 images, you are trying to measure the performance or the accuracy or how accurate your data processing is being happening. So that is how you are trying to train your data. So this is how you need to understand the machine learning concept. So we'll try to implement it practically now. Yeah, coming back to our code, what you need to do is to split the data into training and testing. So we have X and Y data right now, that is nothing but we have X, that is nothing but our years of experience, and Y is nothing but our salary. So what we need to do is pretty simple. So we need to split the data into two parts. So why do we need to split the data? One, to give it to the algorithm for training, and the other part of the data to test it whether our algorithm is proper or not. So that is why we need to split the data between training and testing. So in all the machine learning algorithms, we do the same thing, that is we split the data between our training and testing data. So to split the data between training and testing data, it is very simple. So we'll use this concept called as sklearn library. So using sklearn library, we'll be able to split the data between the training and testing. So that is how you can do. But how will you start it is pretty simple. So we have test and train data split function in sklearn. So you can easily use this from sklearn.model selection. So this is the library. sklearn is the whole library. Will not include everything inside sklearn. So we'll just use this particular portion. So from sklearn.model selection, import test train split. Okay, so now we have included this particular part of library where we want to split our data into training and testing. But what data will be split into training and testing? We have our X data as well as our Y data. So the thing is, both X data and Y data, we will try to split them into training and testing parts. So how do we do it is pretty simple. So we'll name some variables. So we'll create some variables called as xtrain, comma xtest. So then similarly ytrain, and you have your ytest, So you have your X train and X test, and you have your Y train and Y test. So what we'll try to do is pretty simple. So we'll try to include the test and training part. So how do we include the test and training part? It is pretty simple. So we need to split the data into two parts. So that is nothing but we are trying to do are nothing but splitting the data. So how do we split? Using this function called as test train split. So train test split is our function. So we want to split the data into training and testing. So what data we need to split? X and Y. So our data, that is nothing but X train, X test and Y train, Y test, will have the data that is split between X and Y. So X will be split into X train and X test. Y will be split into Y train and Y test. So what is this X train? The data which is going to train our machine learning algorithm. So what is this Y train? That is also the data that is going to train our machine learning algorithm. So what is this Y test and X test? So the data which we will be using to test our algorithm, whether we are able to predict the values properly or not. Okay, so we are using the data X and Y, but we need to mention what is the test size. So what is the test size is nothing but how much of our data is going into testing. So how much of our data is going into testing. So what we can do is either we can mention it in terms of percentages like 0.20, which will tell that it is 20% of data is going into our testing, rest 80% of data is going into training. So the next question is, if I split my data, that is nothing but if I split my data into training and testing, why can't I split? How do I split it, or what is the ratio that I need to use to split it is the question. So right now we can see that this is our whole data and this is our machine learning algorithm to split the data. So this is our whole data. I told you we can't give our whole data entirely to our machine learning algorithm. We need to split some data. So one thing is, we can split the data into training and testing. So what is the ratio? Should I have less training data, more testing data? So what will happen? It is very simple. So when I have less training data, so this is my training data. So if I have less training data and more testing data, so my algorithm, that is nothing but my algorithm, will take my testing data to test the algorithm. Okay, so this data is going to be used to train my machine learning algorithm. But only if I train with such a small amount of data, will I get higher accuracy? So that is the question. So the main thing that I have already told you is, whenever you are using your machine learning algorithms, how much ever data you give to the algorithm, that much accuracy you can expect, because more images you give to the child to differentiate between a cat and dog, so it will learn more and more effectively. If you give only two images, it won't recognize it. So if you give straight images of cat and dog, then it can recognize. If it is another position or if it is in a different orientation, it can't recognize it. So that is very important to understand. So always our training data must be larger than the testing data. Our training data must be around 70 to 80% of the whole data. So when we have whole data, majority of the data must go to training, only the small percentage of data must go to testing. So always it is in the ratio of, this is the training data. So this will be my training data. Always it will be in the ratio of 70 to 80%. So 70 to 80% will be the rate at which I need to give my training data. Testing data is nothing but my 10 to 20% of testing data is enough, because we need to verify how our algorithm is working. So 10 to 20% is enough for testing my data. For training, you need to give 70 to 80%. So what will happen now? This data will be used for machine learning for training. So then that machine learning algorithm, when it has learned, to verify whether it has learned properly or not, we will use our testing data to test whether it is tested properly. So this is the whole concept. So whenever you need to understand, it is pretty simple. Maximum data must go into training, minimum data must go into testing. Why? If you train your algorithm with more data, more accuracy. If you don't train it, then lesser accuracy. So if you don't train it at all, then you are testing with huge data. Obviously, you will get very bad results. So that is how. So more time should be spent for studying in your exam, and then you can answer your whole question paper. But if you don't spend time at all studying, so how can you answer your question paper? So that is simple analogy to understand how this process is entirely working. Okay, we are back and we see that we have our X and Y data that is split into nothing but we have our test size that is 0.20 And then we have an issue here. So what is the issue that we have is pretty complex now. So we have nothing but our data. So if we try to close this, okay, this is fine. So we have our data, nothing but we have X data and we have Y data. So if we go to our data set, so we are telling that this is our X data and this is our Y data. So I need to split this X and Y in the ratio of 80-20. So what is the 80-20 ratio? 80% of data must go to training and the rest of 20% of data must go to testing. But how will the algorithm choose which data should be going to testing and which data should be going to training? So I'll come again. So you have your X and Y and you are trying to split your X and Y. So you are having X and Y. So you are trying to split your X and Y into X train and X test and Y train and Y test. So you understood this basic example, but one thing you fail to understand is, okay, if I split, but how will the splitting take place? So is it in the order of like this 80% of my data will go for training and this 20% of data should go to testing? No, that is not how it works. So that is why we have a variable called as random state. So what is random state is pretty simple. So random state decides how many variables should I leave to go to the training state. So if I choose a variable or if I choose this random state as a variable, so we have a variable called as random state here. So if we use random state variable, so what is this random state variable doing is basically it is testing how the data should be split. Okay, so how the data is going to split into training and testing. That is what your random state is doing. Yeah, so now coming to the point of why do we need random states and how random states are helping us is pretty simple. So once we have our data that is nothing but our X data and Y data, we don't know how the split is going to take place. Whether this data will go to training, this data will go to testing, that we don't know. So if we don't use a random state, so there is a possibility that you don't need to use this random state. So if you don't use this random state, what happens is every time you do the training and testing part, so each and every time new data will go into training and testing. For example, so if in the first iteration of the program that we do, so this data will go to training and this data will go into testing. So in the second iteration of the whole program, so again the data will be the data that is split into training and testing will actually keep on changing every time. So that is the reason why we need to choose a random state. So for a tutorial on this, I will tell you how actually this is working with the help of a small example. Yeah, so now if we try to do this, I'll show you a simple tutorial on understanding how test and train is actually working and why do we need to choose our random state. So one change is, I forgot to tell you, it is nothing but it is a train test split. So this is, made a small mistake. So this is train test split. So again, so it is not test train split, it is train test split. So that is the function. So what you can do right now is pretty simple. So whenever you want to see how the actual splitting is taking place, so which data is getting split, so what we'll try to do is we'll comment all these graphs because we want to see how the data is getting split. So we'll comment all these sections and we'll try to see how my actual graph is splitting. So I will try to print my x underscore test. So if I want to try to print my x underscore test, simple thing. So this is my x underscore test. So what is x underscore test? So inside my X data, so some of my data is going to split into training. So which is the data that is split into my testing? This is the data that I have split into testing. So what happens is pretty simple. So whenever I want to try to rerun this code again. So if I want to rerun this code again, so I will rerun it. See, the 8.2 data changed to 8.7, 7. See, every time we are getting the new test and train split data. So this is the problem that we have. Why do we tell this is a problem is, suppose I have made a mistake in my program. So suppose I have made a mistake in my program, but I want the same data to be executed. So if I want to check the accuracy or if I want to execute the program or if I want to test my model, my X and Y split data should not be changing always. So it should have a constant value. So what you will do is, you will set random underscore state as a variable. So you can set it as any number. You can set it as 1, 3, 5. It doesn't make any difference. But once you set it to one number called as 18 or 354, so any number you can set. But once you set it to that number, so I will set it to 3. What happens is, it will not change. That is nothing but the split will not change. So whenever I have my random state is equal to 3, this is my values that I am choosing it for X test. So again I will go and rerun the code again. So if I go and rerun the code again, my data is not changing. So again if I go and rerun the code, so how many ever times I run, the values are same. So this is the reason why we need to use a random state. So why we need to use random state is pretty simple. So whenever we have splitting our data into X train, X test and Y train, Y test, the main problem is we have our data being split into two different parts, training and testing, that is done randomly. But the problem is whenever you do it randomly every time, so I will have some 70% data for training and 30% data for testing, or 80-20, but the 20% or 80% keeps on changing, then I can't train my model properly. That is why I need to have fixed data. That is nothing but any data inside this should be 80% should go into training, 20% should go into testing. But which is the 80% we need to select using that random format. But after selecting it also, in the next iteration it should not change. So how will it not change using the next iteration? Using this random state. So random state, what it is doing is, for every number it has some random, whenever you assign some data, so it randomly picks up some data for training and testing. But when you assign random state, next time also the same state will be present, so the data won't change. So if you don't use random state, every time your testing and training data will be split into different ways because of the randomness of the nature. So what is happening is pretty simple to understand. So whenever you have your data that is being split into training and testing, so you need to understand that the whole data is split into different parts. You don't know which is going to where, because this data can go to training, this data can go to testing. So this is a random process. But what we are telling you right now is, if you don't use this random state, every time new variables will go into training and new random variables will go into training and testing. But if you mention this random state as some value, once it does a random procedure of selecting this is for training, this is for testing, it won't change again. So that is why we need to use this random state. So random state can be anything. For example, 300, 400 or 500. If one time random state is assigned, so I will assign random state as 34 and I will try to run this program. So it will load some random values. Even we can't predict which is the random values it will load. But if we try to run the same code again, the same values will appear. That is the reason I am telling, once we are training some data, we should not jumble it. So that is what it is doing. So very important to understand why we need this particular thing. It is because it is helping us, make us understand that the data should not split into different parts. Okay, so now we understood the importance of splitting our data into training and testing. So after splitting our data into training and testing, we will not know how the data will be split. That is because it is a random procedure. But we know that when the data is split into training and testing, so we want the data to remain as it is even in our next iteration. So if I make a mistake here, if I run the program, again it will be splitting into different parts. That is quite an inconvenience to me. So what I will do is, I will set a random state. So random state can be any number that you want to choose. So I can set it as 34, 45, anything. So once you set the random state, so the same values will appear. So even we don't know what is the values that will be appearing for the random state. But once you set your random state as 34 and try to run your code, but you can get to know what is the values that are appearing, and the same values will be appearing in our next iteration also. So that is how things are happening here. Okay, so they're done with random state, but the next part is pretty simple. So we have split our data into training and testing. So now we need to use our machine learning library. So how to use our machine learning algorithm? So using the library called as using sklearn dot linear model. So this is our library dot linear underscore model. So sklearn is a big library. Inside lot of functions are there. But in sklearn we have a model, we have a linear model. So that is nothing but a part of sklearn. So we'll import linear regression. So what we are trying to do here, pretty simple. So we have our sklearn dot linear underscore model. So this is nothing but the linear model that is there inside the scikit-learn library. But within that we have a small model called as linear regression. So every time I am telling you here, we are not taking in all the libraries. So we don't import sklearn as a whole, but we will take some sub libraries. So what did we include in sklearn first? That is nothing but train test split was the function that we included. But here what are we doing? We are including a small part of the library that is nothing but linear regression. So what we will try to do is we will try to use this linear regression function for our data. So we will try to initialize the data to our linear regression. So we'll enable the learning of our data to the linear regression. So then we will try to understand how we are able to predict the results. Okay. So what we'll do is pretty simple. So we'll take in linear regression. So we need to initialize a function. So I'll call a variable called as regressor. So I will initialize the function. So that is nothing but linear regression. So I'm giving another name to my function. So instead of using linear regression again and again, I will use it as a variable regressor. So I can use my regressor in place of linear regression function. Okay. So now I have initialized my linear regression function. So linear regression is finding out the relationship between my x and y data. But how will my x data and y data that is in this data set understand, or how will my algorithm learn to this data? So how will my linear regression know that this is the x data and this is the y data? So that is why we have a function called as fit function. So what we will do is we will fit our data. So regressor.fit. So what should we fit? The training data or testing data? What data is used for training, guys? Only the training data. So x test will fit and y test will fit. So what is fitting is pretty simple to understand. So whenever you have your concept of linear regression, your linear regression is an example of formula. So it is just a simple formula where you need to calculate the distance between the lines, and then you need to calculate this mean squared error, that is nothing but the smallest distance that is there between the different lines, and select the best fit line. But which data should it select? Which data should it use is the question. In order to make our machine learning algorithm learn with our data. So what is our data? Our data is our x data, which is nothing but our years of experience, and our data is our y data, which is nothing but salary. In order for our model, in order for our linear regression algorithm to understand which is x test and which is our x data and y data, we need to fit the model. So that is why we have a fit function that is nothing but fitting our data. So what is fitting? It is telling the algorithm that this is the x data, this is the y data. So please find out the relationship between x and y and see how it is actually getting plotted. So this fit, what it is doing is, it is telling it this is our x and y data. So please evaluate the algorithm for our x and y data. So this is our data. So our algorithm should learn according to this x and this is y. So this is the fit function. So understood fit function, it is telling that algorithm is just a simple set of mathematical formulas. It doesn't know which is salary, which is, even it takes in salary, even it takes in number of apples, even it takes in number of people. So what should it take? You should decide. So that is why you are telling that my x data is nothing but my number of years of experience. So my y data is nothing but the salary. So this is how our model is actually learning with our data. So our machine learning algorithm is learning with our data. So after doing that, fitting the data, so we should not use the testing data, we should use the training data. Why? Because testing is just used for testing our whole program. We need to use our training data. Why? All the important parts, that is 80% of data must go into training, only 20% of data must go into testing. So how have we done that? We have split our data, that is x and y data, into train and test for x and y respectively. So test size is 0.20, meaning that our testing size is 20%. So 20% of our data is used for testing. Okay, so this is how we are implementing our particular data into the algorithm. So after that, it is done. So our algorithm has learned with this x data and y data. We need to predict something. So what will we predict is nothing but whether our data is proper or not. So what we will do is we will try to predict. So what will we predict? This is the next question. So what we have here is, we have our x train and x test and y train and y test. So we use our x train and y train to train our linear regression model. So our linear regression model is trained successfully with this x train and y train model. So what did this linear regression do? It found out the relationship between your x train and y train. So it came up with a formula that is nothing but y is equal to mx plus c formula to draw straight lines on the data. So since we have already seen here our data is not proper, that is nothing but our data is not a regular straight line data, it has lot of other points, so we need to draw the best fit line. So all those calculations this function has done. Okay, so to which data our function has calculated? To this x train and y train data. Now what should we do is we need to predict our data. So what data will predict is y underscore predict is our new variable. So from which we will predict? From regressor is the function which is already learnt using this fit. So we have already made it learn using fit, but we should predict using the predict function. So using this predict function, we will try to predict the data. So what data we will predict? If you want to predict some y data, so what is the y data? It is nothing but our salary data. So what is the x data that I need to provide? Years of experience data. So why we split the data into training and testing, here we will understand. So we will use this model, that is nothing but our linear regression, to predict for our x underscore test. So what is x underscore test? Our data that we used split for training. So where we have our data that is split between training and testing. So this x underscore test, we are giving an input to our linear regression model. So what it should do? It should predict the y underscore predict. So what is this y underscore predict it is doing is, this is using the linear regression machine learning algorithm which has learned with our x train and y train data to predict for our x test values. So if we give x test value, it should predict the values. So what we will try to do is we will try to print it. So we will try to print y underscore predict. We will try to print. So while printing, okay, one error we got. So linear model, okay. In linear model, L is small here. Sklearn.linear model, L is a small lettered word, so that is fine. Okay, so this is the predicted data that we have. So what we are trying to do here is pretty simple. So once we understand this whole concept, the whole machine learning program becomes very easier. So what we will try to do, we will try to understand this particular part. So this is nothing but we used our linear regression model. So this is initialization of linear regression model. Then we are training our linear regression model using our x train and y train. So now our model is trained. But now we need to predict using some data. So what are we doing to predict? We are giving our x underscore test data. So if we give x underscore test data, it should predict, it predicted some value. So what is this value predicted and how can we check whether this value is accurate or not? It is pretty simple. So we have our x underscore test data which is related to what? Y underscore test. So we'll see, we'll create a data frame which will give you a better understanding. So what we will do is, we will create a data frame called as original data. So we have our original data. Original data is equal to pd.dataframe. So why we need data frame? If you are using two different, that is nothing but if you are using multiple columns to store in a particular data, we need a data frame. So what we will do is we will create a data frame between x test and y underscore test. Okay, so now if we try to print this original data, so this is our original data. So what is our original data out of this entire data set? So my data is split into two parts, that is your testing data. So what is this? This is x test and this is the corresponding y test. So for 93950, or what we will do is we will see here what is the data that we have printed. So we have printed our x test and y test. So what is our x data here? Years of experience, and y data is nothing but our total salary. So to understand this, it is pretty simple. So we'll go to the program. So we have our x test and y test data that is being printed. So what is being printed here? Our x test and y test, the data that is being printed. So what we need to understand from this is pretty simple. Okay, so when we see the original data frame, you can see that for the data that is nothing but when we have data that is 6.0, when it is 6, it is 93940. So we can see that When it is 6, it is 93940. So that is how you are getting your data printed. So what is happening while splitting is pretty beautiful to understand. So you have your X data and Y data that is being split. So how it splits is X is not getting split separately and Y is not. This whole like the whole row is getting split. So for example, these 4 rows are going for training and these 3 rows are going for testing. So it is splitting row wise. So there is a relationship between your X test and Y test. So what is the relationship is they belong to the same row. So what we are trying to do in turn is whenever we are training that for 6 training using X train and Y train. So what are we getting at the end is pretty simple. So we trained using our algorithm linear regression and we found out that this is how we are training our data. So we trained using our X train and Y train. So what will be our X train and Y train? We can print that also here. So print X underscore train. So this is our training data. Print Y underscore train. So this is our okay, so this is our training data. So this is our X train and Y train that we are trying to print. So if we try to print it, so it will be in the form of array. So that will make you get confused. So what we'll try to do is we'll use this data frame itself to print our data. So we'll try to print this as data. Okay, we'll create for our testing and training data. So we have our train data here. So if you want to print this, so we have our X and Y that is there. So this is our whole part. So this is nothing but out of my all rows, what I did was I split my data. So how I split my data for 4.9. So we can find 4.9, 67938. So this is the first row. So 5 or what we can do is 3.2. So 3.4 or 3.2, 54445. So it chooses randomly the different rows. So that is how you are splitting your data into training and testing data. But in training and testing data also you can split it. You can have 2 parts, that is X train, Y train. So X test and Y test. So please understand this, whenever you are splitting data, it will be split into 2 parts. One is training data and testing data. The other thing that it will be split into is X train and Y train, X test and Y test. So what we are trying to do here is pretty simple. So we have trained with the help of our X train and Y train, and we are trying to predict, or we are trying to predict some values using your X test. So whenever you predict your X test, what you will be getting is actually Y test. So this is the thing that you need to understand. So whenever you are trying to predict your X test, what are you trying to get is nothing but Y test. Why? Because your X test is nothing but the columns which are equally related to your Y test also. Whenever you split the data into training and testing, so you have training, consider this as your testing data. So you are only considering one testing data. So when you consider only one testing data, what you have is X underscore test is your X data, Y underscore test is your Y data. So whenever you are trying to predict, whenever you are giving a machine learning algorithm, predict my value for X underscore test. So what should it predict at the end? It should predict your Y underscore test. So X underscore test will give you values of Y underscore test. So please understand this. It is very important to understand. So whenever you are trying to predict any data, you are trying to predict the other half of the data. So whenever you are giving X underscore test, the corresponding column, that is nothing but you have this as your X underscore test, it should predict your this as your Y underscore predict is the machine learning predicted value of this Y underscore test. So it should be almost equal while you are trying to predict. So it should not be anything different. Yeah, so that is with this entire thing. So that is the whole thing that you need to get. So I will tell you the whole part what we did right now. So what we did right now is pretty simple. So we'll show it with the help of a graph. Okay, so this is better to understand what we did. So we had a CSV file called as salary.csv. Okay, when we have this file called salary.csv, what did we do is we had 2 columns. So X is nothing but my years of experience. So Y is nothing but my salary. So what we did was we split the data as X and Y. So what is X and Y? X is having years of experience and Y is having salary. But in this data, what we are trying to do is pretty simple. So for machine learning, we already told you this is our X data and this is our Y data. But we need to split those data into training and testing. So what we did was, this data, entire data, what we did was, we choose a majority of the part as training data and testing data. So this is our training data. So again, we'll have a division between our training data. So this training data, so this is the training data that we used. So this is our training data. So then coming back, in this training data, we also had X underscore train and Y underscore train. So this X underscore train and Y underscore train, they are not separate. So how it is splitting is, it is splitting with the help of rows. For example, if you have a row of 4 and 55, 794. So my training data will include two parts. So it will also include that it is a correlation between the two parts. So if it is including 4, it should include 55, 794. So it is not splitting individually between your different columns. So it is splitting row wise. So that is very important to understand. Splitting the data for training will not do it separately between column wise. It is doing it row wise. Okay. So once you split the data, it is pretty simple. So you have your training data also being split. So your training data is also being split into two parts. So what is it being split into? It is being split into your X underscore test and Y underscore test. Okay. So now this data I am giving it to my linear regression. So this data I am giving it to my linear regression. So after giving this data to my linear regression, so my linear regression is capable of predicting. So now it has become capable of predicting after I told that this is the data set that I am giving. So for example, if X is equal to 4, Y is equal to 55794, and similarly I have given all the relationship. So now what we will be trying to do is, we will be using this X underscore test data. So we will be giving X underscore test data to the algorithm. Okay, since this has become capable because it has learned that what is the relationship between your X underscore data. So once we give this data, to the algorithm, so it will predict Y underscore predict. So very important to understand. So it is predicting your Y underscore predict. So it is not the data that we have. It is the data that the linear regression predicted. So this data predicted that this is Y underscore predict is the data that the linear regression predicted. But what is Y underscore predict actually is nothing but it is equivalent to your X underscore test. Sorry, Y underscore test. So these two are equivalent. So why these two are equivalent is, since if X is equal to something, Y is equal to that, it is nothing but the testing data set. But whatever your model is predicting is that. For example, I will give you a simple example. For if X is equal to 3, your salary would be somewhere around 40,000 rupees. Okay, so this is the actual data that I have. For I will take the data set itself. So if X is equal to 3, we will have 60,150. So for X is equal to 3, we will have 60,150. Okay, so now what we will try to do is, we will try to give X to our algorithm. So we will see what is our algorithm predicted. So if our algorithm is predicting somewhere around 60,000, so that is the value that our algorithm predicted. So this is how your machine learning is working. So basically you had your data, you converted the data into X and Y. So then having your X and Y, so it is splitting your data. How is it splitting? It is splitting into row wise. So it is not splitting X separately as columns, so it is splitting row wise. So you have a relationship maintained as it is. So whatever is your X value, the same Y value, that is split into nothing but our training and testing set. So whenever we give our X train and Y train, that is telling us for X is equal to 3.2, Y is equal to 64,435, X is equal to 4, Y is equal to 55,794. So we are training our linear regression giving this data. After training it, we need to test it, right? So how will we test it? We need to give X value. So what X values we will give? The data which we had here, so we had small part of data which was our testing data. So we will give our testing data to see what is the value that it will predict. So whenever I give my testing data as 3, so actual value is 60,150, but our prediction, that is nothing but our linear regression, will predict some value. So if these two are similar, so if 60,150 and 60,000 are similar, then our algorithm has predicted properly. If our algorithm predicts, for example, 20,000, then it is wrong. That is how you cross-check the accuracy of the algorithm, and that is why you need to split your data into training and testing. So very important concepts here. So that we learned now. So okay, so we understood that this is the predicted data which the algorithm has predicted, and the corresponding data which is there in our data set is nothing but our y underscore test data. So we'll compare both the data. So what we'll try to do is we'll compare y underscore test and y underscore predict. So this is nothing but we are comparing our y underscore test and y underscore predict. So if we try to print our data, nothing but we'll try to print our original, we'll call this as cross-check data. So cross-check data is nothing but it is trying to cross-check the data between y predict and y underscore test. So we'll try to cross-check the data. So cross-check data is loading like this. For the original data is this. For 93,940, it predicted it as your 81,898. So almost similar prediction. So for 56,974, so it predicted as 62,000. So that is how your prediction is happening. So still more details if you want, you can even include your x underscore test. So your x underscore test that has given that had been given as the input to your whole machine learning algorithm. Yeah. So now you can see that I have printed my x underscore test also in a separate part, and y underscore test and y underscore predict. So what we are trying to do is pretty simple. So this is my x underscore test. For 6, it should predict as 9,000. The original value is nothing but for 6 it is 93,940. It has predicted as 81,898. For 4 it is 56,957. So 56,957 is my data. So that is, it has predicted as 62. So some variation is there because of the algorithm. So how algorithm is working is it has drawn a better best fit line. So what is the value that we are getting in best fit line? So that is what we are testing it out. So 10.5 years of experience. So the salary should be 1,21,872 for, okay. So the predicted value is 1,24,664. These two are telling us how our linear regression accuracy is being in. So this is how we actually do our machine learning part. So this is the entire thing about how we do machine learning. So very important to understand how we split our data into training and testing. So how we fit our model with our data to make our model learn. So after fitting it to test, we are giving the testing data. But I have a question right now. So we had some testing data and I gave it, but I want to give my own data. So if I want to give my own data, what I will do is, so I will give it as y prediction 1. So this is the variable. So if I want to train my own data, that is nothing but I want to see how much of salary will I get for if I have an experience of 6 years. So to give that, you must give an input of list of lists. So it is nothing but a NumPy list that we are trying to give, because the data that is split into training and testing will be in the form of list of list. So the input also should be given in the form of list of list. So if I want to get how much of salary will I get for 19 years. So if I don't have data of 19 years. So that is nothing but found by extrapolating my graph. So if I want to see how much salary I get for 19 years, so I will use my 19 as the number of years. So that will be stored in y predict. So if I want to print y underscore predict 1, so that will predict actually how my data is going to get split. So I will remove these two print statements. I will just print what is my salary for my 19 years of experience. So this 19 years is not there. Using our x-train and y-train data, our regressor understood that this is how my data needs to be split, or this is how my data needs to be trained with x and y. It found out the relationship. So this is how it is predicting my data for 19 years of experience. So for 19 years of experience, my salary would be 2,05,445 rupees. So that is how it predicted. But one more thing we need to understand is how did it predict, and the mathematics behind it is pretty simple. So we have discussed the mathematics also in the previous session, that how it is predicting it. Basically it is trying to find the best fit line. So there is also a method to find out the coefficients of the best fit line. So I will tell you how. So we have two functions, that is nothing but regressor.intercept and regressor.coefficient. So this will find out the coefficient and the intercept. So what is the coefficient and intercept? So whenever you have your equation straight line that is drawn, that is of the form y is equal to mx plus c. So what is the coefficient is nothing but your m, that is the slope. So what is the intercept? That is the c. So y is equal to mx plus c. So m and c value we can see what is actually the m and c value which are regressor calculated. So you can see that this is what our regressor calculated. So our regressor calculated that our value of m is nothing but 24876 is our nothing but our, what is that? It is our intercept. Okay, that is our c value. 9503 is our x value. So actually what it did was, our whole regressor studied all the values of x and y. So basically it predicted that y is equal to, okay, so basically try to predict that y is equal to 9503x plus 24876. So this is the equation that it predicted. So this is the the slope of the line. So that is the coefficient, and this is the intercept. So when we draw the line with these parameters, so we will get a straight line. So whatever values that is we are predicting x versus y will be according to this particular straight line. So this is the coefficient, and that is the nothing but the slope for the best fit line. So we'll see how the best fit line is also drawn. So how will we do that is with the help of our matplotlib. We'll see how it is getting drawn. So what we'll do is we'll plot a graph of scatter graph of x train underscore y train. So this x train underscore y train is all my regular data. So this is my x train underscore y train. So what we'll try to do is we will try to plot the straight line. So how will we plot the straight line? So scatter is nothing but my dotted points. Between that I need to plot a straight line graph. So the straight line, if you want to plot, it is a plot command. If you want to plot dots, it is scatter command. So we will plot this particular data. So what we will plot? X train versus, so y train is the data, but if I want my linear regression to predict something, it is nothing but regressor.predict. So regressor.predict x underscore train. So this is also simple to understand, guys. So why we are using regressor.predict is the regression model is predicting this. See this, what we are plotting is, we are plotting x train data versus y train data, which is giving you all the points on the graph. But here we are plotting a straight line, which is the best fit line. So how will you get the best fit line? We will use this predict model. So regressor.predict model. So if you predict the x train model, so it will give out the correct y coordinates for plotting. So that is how you will get the best fit line. See, this data is the random data. So this data is the best fit line. So to plot the best fit line, how will you plot? It is x versus the y predicted. So what is y predicted? It is nothing but predict of x underscore train here, because we are plotting x train versus y train. So we can see how this graph looks. It is plot.show. So you can see that this is the best fit line, where it has actually, what it has done is it has tried to calculate the distance between each point, squared it, and found that this is the best fit line. So how did we find the best fit line? We plotted our x train and y train. So this is all the scattered points that we have. To find the best fit line, what did we do is, here we scatter plotted, but here we use a straight line plot. But what was the coefficient of the straight line plot, and how did we find out is using the x train. So we will ask the model to predict what will be the y values for our x underscore train. So this predicted values will always be in the straight line, because our the whatever operation we are doing is a linear operation, so that is why it is a straight line. So this is the best fit line. So we can find out best fit line by plotting out your x versus y first, so to get all the scattered points, and x versus the regressor predictions values, that will be a straight line, because linear regression always predicts a straight line. So that is what it is doing. It always draws a best fit line. That is what is your prediction. Your prediction is not something that is like out of the box, or it is not a magic. It is nothing but for a straight line. If you draw the x versus, if you are like extrapolating your x values, you will get y values. If you are extrapolating your like x values, you will get your y values. So that is what is happening in this particular graph. So this was a simple explanation of how a linear regression is working. So you can take in different data sets and you can start working with linear regression. So that is also possible. So in the next session, what I will be showing you is a simple tutorial on linear regression with multiple values. So that is what I will be showing. So linear regression with, it is also called as multiple linear regression. So that also we will be doing. So this was the first like the basic machine learning algorithm. So that is nothing but a linear regression that we explained. So thank you guys. I hope you had a wonderful session ahead. So I will be posting this program as well as the data set onto your code, so you can see in the discussions and you can download and you can execute the code. Thank you.